how many charge per second, which this we call it measured as ampere. So 1 ampere means 1 coulomb per second. We can say charge, how many charge, 1 charge per second. And then volt is 1 coulomb may be moved between 2 points in space of 1 joule of work. Means, okay, volt is work or energy required from one charge to move from 1 point to another point. So that is volt. Okay, or we got later we will see what is voltage, and then what is rate work is done or energy expended. And the watt is defined as 1 joule per second. Okay, or we can say this. Yes, 1 joule per second. Energy. All right. So again, in SI units used in electricity, we have volts, V, ohm for resistance. Sometimes we can use the symbol, sometimes we can just put alphabet O. Kita akan eja saja, OHM. The amperes unit is A, coulomb C, watt W, and joule J. Alright, basic information about electricity. Electric current is the flow of electric charge. Conventionally, this is a flow of positive charge. Okay, so we have source, source of electricity. For example, this one is battery. So they have a positive terminal and negative terminals. So the charge will flow, positive charge will flow from positive pole to negative. Okay. Meanwhile, for electron, flow is opposite way. Okay. Remember, positive sign is longer than negative sign. All right. So this is okay. Current is measured. Okay, electric current, dq over dt. This similar the previous definition lah. So current, arus current or in Malay we call arus, is how many charge flow in 1 second, dq over dt time. Alright, and then current can be divided by two types, which is direct current. Another one is alternating current. So both is different. So direct current, as you can see, this current to time graph. So direct current has a very uniform, only one magnitude. If this is 1 ampere, if there is a supply 1 ampere, it will continuous. The sources will supply similar uniform current during across the time. Okay. Meanwhile, alternating current is fluctuating. It's very sinusoidally. So sometimes it's at a maximum magnitude is similar, but sometimes it's in a positive state and sometimes it's negative states. Okay, there is a purpose of this behind this both two. Okay, let's see the definition first. A direct current is a current that remains constant with time. The symbol I used to represent such constant current. So they use I, large I. And alternating current is a current that varies sinusoidally with time, and a time varying current is represented by small I. Okay. So if some of you don't know why there are two types of current, so normally in Malaysia for electrical supply, domestic, the current, the source of current or energy will be sent to building by alternating current. Okay, so from the power plant to the power transmission grid line to the building, the electricity is sent by alternating current, because alternating current has much more advantages compared to direct current, due to it can reduce heat loss. It can reduce heat. Okay, it can also transform. It can be transformed to high voltage to low voltage is very flexible. That's why they have a transformer. So the transformer can transform alternating current, but direct current cannot. And then the fluctuating, the sinusoidally, this can reduce heat. Okay, during if they send current through this direct current, always at the very maximum value. So it will apa, uh, the cable will have heat load lah. Okay, dia akan memanas dan not very sustainable for the lives of the cable. So I will not discuss further in detail. You can check the difference between alternating and direct current. Okay. So as I mentioned before, example, the alternating current is from the source at the building, socket outlet at the house using alternating current. Meanwhile, direct current is such as a battery. Okay. Battery, and then the solar power that's saved into a battery. Okay, then how about our equipment, such as laptop? Okay, normally a laptop using direct current. Okay, like this. So since our house or our building have a supply of alternating current, but some of our equipment using direct current. So that's why if if your electrical equipment has adapter, then ada adapter. So adapter actually change from alternating current to direct current. Okay. So for some of equipment, it is better to be operated in direct current because it is much more maybe efficient. But to send power, to send electricity from one point to another point, very long distance, it is better to send the current by alternating current. Hopefully you get what I mean. Kalau tak faham boleh tanya. Ada yang nak clarify lagi tak? Apa beza dia?
Tak ada, Doktor. Okay.
Dua ni dicipta oleh orang yang berlainan lah. If not mistaken, direct current ni antara pelopor dia adalah Thomas Edison. Okay, alternating current based on Westinghouse, I think. Westinghouse. So sedikit pada history lah. Both are researcher in America during that time. So they want to. So Thomas Edison dia cipta direct current. Dan another one, Westinghouse, dia suggest alternating current. So dia masa tu first time dekat Amerika untuk jadikan satu sistem untuk Amerika lah. So dua-dua ni melopor untuk kerajaan supaya guna direct current ataupun alternating current. Tapi dalam proposal tu lastly yang propose alternating current menang lah sebab dia lebih efektif, lebih efficient. Direct current dia cost efektif lah, jadi mahal lah. Alright, so voltage. Let's see. Voltage is also called as potential difference. Why it is called as potential difference? Because it is actually electromotive force. So voltage is required to force the charge to move from one point to another point. Okay, so it means the charge cannot move by itself. So it needs some force. So voltage you can imagine it is as a force. Force the current to move from one point to another point. So you need is volt, and we can measure by voltmeter. Next, I think I will skip into energy and power. So we can calculate power. The power equal to voltage multiplied by current. Okay, so unit is watt. So you need to remember this if this is important. Alright, next we go to simple circuit that we will learn today. So the name is Ohm's law. So when we can use this principle of Ohm's law, when the circuits only containing resistive elements. Okay, so only no other another elements except for resistive only. Only equipment with resistance only can use this Ohm's law. Because this is very simple circuit, right? So Ohm's law states that the electrical current flowing in a circuit is proportional to the voltage and inversely proportional to resistance. Means I equal to V over R. Unit is ampere. Okay. Increasing the resistance of the circuit will lowering the current flow of the charge. Okay, like this. If the current increase, so is proportional to the voltage, so voltage also will increase. Meanwhile, it means when the current increase, the resistance is reduced. Okay, but if the resistance increase, uh, the current will reduce and voltage also will reduce. Okay, so you need to remember this. So we can arrange various arrangement. If we want to find voltage, it means I versus R. If we want to find I, it means V over R. And when we want to find the value of R, it is V over I. Okay, let's see to this example. Okay, so remember the equation. So given the voltage is 24, okay, and then resistance is 12 ohm, so we can calculate current directly. This is a series circuit. So the current is we just divide V over R, so we can get 2 ampere. Meanwhile, if we check resistance, if 24 divided by 2, it means 12. We can get 12 ohm. And power means we multiply voltage multiplied by current, which is 44 multiplied 2, it is 48. So straightforward, you can use this. All right. But the main things you want to know are the slightly complicated calculation. If by knowing the type of circuit, it can be series, it can be parallel, and it can be combination of series and parallel. Okay, let's see series. As this one, I need you to really focus and understand the concept. Okay, a series circuit is the simplest circuit. The conductors, control, and protection device, loads, and power source are connected with only one path to the ground, to ground of current flow. See, so looking at this figure, series circuit means all the resistance is connecting through only one wire, okay, continuously, right? The resistance of each device can be different. So R1, R2, and 3 resistance can be different. Yes, but the same amount of current will flow through each component. Because of this series, the current I will be similar at all points. If you measure here, or if you measure here, for series circuit, there is only one value of I. Okay, because it is a series circuit. All the resistance installed in series. The voltage across will be different. If the path is broken, no current flow and no part of the circuit works. So of course, the disadvantage is series. If the circuit broken, so there will be no equipment will be working. When the circuit will be failed, right? Meanwhile, the explanation for this, the voltage across each will be different. This means, imagine if resistance is different value, value one, value R1, R2, R3, and 4. If this is all is difference, so it means V also will difference. The voltage of each this one pair is also different. Okay, but I is similar. Right, that's one you need to understand. Try to understand in maybe 2 minutes. Okay, look at this slide, read, and try to get the information. Again, in series circuit, resistance of each device can be different. R value can be any, and the voltage will reflect the value of R. So value voltage pada setiap resistor ni pun juga berubah-ubah bergantung kepada nilai R. Okay, okay, what is the difference between V1, V2, V3 and this main V? Right. Uh, V is V supply, main, okay, main. But in series circuit, when the electric flow, the voltage will be share. Okay. Uh, the imagine this is total. So every time the electric flow through each resistance, it means some of resistance use some voltage. Resistance 2 take some voltage, resistance 3 take some voltage until it's equal. So it means this voltage at resistor must be equal to voltage supply. Okay, I think better to look like this. Okay, right. Series circuit. V totals mean V1, V plus V2, V3. So we have V supply here, and at each resistor, it has its own voltage because resistor will absorb, we can say in simplest word, absorb some voltage. So here will be V1, at R2 will be V2, at R3 will have V3. So total of V1 plus V2 plus V3 should similar to V supply or V total. Okay. Since V equal to IR, then V total means I1 R1 plus I2 R2 plus I3 V3. Okay. Meanwhile, total resistance is we just combine, sum up all the resistance. It's easy. R1 plus R2 R3. Okay. Okay. Meanwhile, current. Okay. Current is voltage divided by total R. So what we can say that voltage, you can use voltage supply, main voltage divided by resistance total, in total resistance lah. So we can get I. Okay, sorry, I, current. So this I that you obtain is similar. So this circuit will have uniform I value. For example, I1, okay. If at R1 you measure 1I, at R2 you measure ampere here, and at resistance 3 also you put some ammeter and you check. So what happen is the value will be similar. So main I is equal at every location. That is the characteristic of series circuit. So this need to be remembered, this concept. Okay, this one. All right, example, we try to calculate total resistance. Given this circuit, we have a main supply of 150 volt. Resistance 1 is 5 ohm, resistance 2 is 10 ohm, and resistance 3 is 15 ohm. So solution is very simple. Our total is with sum up all. Okay, so 5 plus 10 plus 15, we obtain our total of 30 ohm. Okay, so after that, calculate total current. Okay, total current, we can use voltage supply. Total current, total voltage, 150 divided by total resistance. So we can get I equal to 5 ampere. So 5 ampere will flow across the circuit. Or then we can calculate voltage at resistance 1, voltage at resistance 2, and voltage at resistance 3. How? Because the uh, current is uniform, so to calculate V is I multiplied by R. Rn Rn means each R, each resistance. I is I that we obtain. Current is what we obtain, which is 5. So V equal to 5 plus multiplied by Rn. So like this. So at R1, so I equal to 5 multiplied by 5, it means 25. At V2, resistance is 10, so V2 is 50 volt. Meanwhile, at R3, resistance is 15, so V3 is 75. And when you sum up of this, it is 150 volt, similar to voltage supply here. Right. So as you can see, I is similar because this is series, is the resistance connected by series. Okay. I think better to get better understanding. Let's do some to do this question again. Okay, you will do. Okay, the best way is to practice. Right? Make sure you remember. Okay, using the same similar circuit, similar question, but I will change the value. Okay, example, this one R1 is 6 ohm, R2 is 8 ohm, and R3 is 10 ohm. Okay, right, try to calculate this. I give you uh, 6 minutes, so 4:52. We can discuss. I will ask the luckiest person to inform the answer. Okay, calculate this. Similar question but different value. Okay, and then okay, calculate total resistance, calculate total current, and each voltage at each resistor. Right. Okay, saya rasa soalan ni simple saja. So kalau ada yang dah jawab, mungkin boleh share lah dekat chat box. Okay. So R total berapa dapat? Senang je guys. Okay.
24.
24, alright. 24 ohm. Jangan lupa,
24 ohm.
don't forget the symbol. 24 ohm. And then current. So current, if you use the equation I equal to V over R, means V is 150 divided by 24. It is equal to
6.25 ampere.
6.25 ampere. And then V1. See, V1 means example of calculation, which is okay. So ampere is similar, 6.25, 6.25, 6.25. So the difference is resistance. So this one is 6, this one is 8, this one is 10. Okay. V1, V1, V2, V3. Oh, ada yang okay, this one 37.5 based on Liu Zhengyong di dalam link. So I assume betul ni betul. Oh sorry, 37.5 and then 50 volt, lastly 62.5 volt. Okay, so hopefully this is correct. So this is how, this is very simple, basics, but you need to understand. All right, good. Make sure you remember this. Let's look at different example. So we have a supply of 12 volt and then 2 resistance, and then calculate voltage. Similar, I think similar as previous. So first step normally we will calculate R total. So this use R null, so R total. So we have 6, and then try to find main I, which is 2 ampere, 12 divided by 6. Okay, and then calculate V at each R. So we can get V at R1 is 4, V at R2 is 8. And we double check, 8 plus 4 it's 12, and similar to the main supply. Right. So it's easy, right. So the main things for series circuit, you need to remember this. This one, this page is very important. So I put star here. Remember this. Okay, let's look into a parallel circuit. Right. Okay, parallel circuits is look like this. It can from mains, from supply. Okay, it can be have a branch, branch. Okay, so the one of the advantage, if inside the branch, if there is a failure, putus, cut in the branch, so the current still can flow at another path. So that is one of benefit of parallel circuit. Okay, but if in series, if the cable cut, so there will be no current supply. Okay, let's see the concept of parallel. Each branch receive source voltage. This you need to remember. Each branch. So what is branch? This is branch. Every split, every branch has received source voltage. So if the circuit have 2 branch, this is 1 branch. So R1, R2, and then this is another 1 branch. R3, R4. Okay, example. So what 2 branch? So each branch receive source voltage source here. So example, voltage source is 12. Okay, so here will also 12 voltage, here will also 12 voltage. Okay. Sorry, I made mistake. We cannot say like this. Yeah. Okay, sorry, yeah. If only one branch, sorry, if only one branch. If branch like this, simple. So this branch will receive similar voltage, but the one that I draw before, if have two branch, we have to consider that is already series. Okay, so cancel. So if there is one branch, the voltage of the branch will receive a similar. The current flow through each branch can be different. Okay. This means if we have supply here, maybe too small. Okay, again, the principle of concept of parallel number one about voltage. About voltage. So if there is a one branch, we supply. And this is R1, this is R2. So and we have I current, I total. Okay, so in this case, if we measure voltage at the branch, we put voltmeter at the branch, so the reading will be similar to voltage supply. Okay, all right. But how about current? So the current flow, each branch can be different. Okay, so means if the resistance is different, okay, if the resistance is different, so inside the branch it will be different current. It can be, for example, I1, this can be I2. Okay, if the resistance is different, so the current flow to each branch also will difference. But I1 plus I2 equal to I total. This one plus is actually sum is this, because it has branch, it will flow separately, depends on the resistance, and combine again here, and then become I total again. All right. The resistance of each branch can be different. Okay. All right, like this. Okay, this one is easier. So we have one parallel like this. So this is actually another drawing is like this. Okay, so this is R1, R2, R3. So means all here have similar voltage. Okay, so V1 equal to V3, V. If here has V, V1 equal to V2 equal to V3 equal to V. Okay, and then I means total I means I1 plus I2 plus I3. Here has I1, has I2, has I3. Okay. And then how to calculate R total? You have to use this format. R total to combine. Okay. To calculate, to sum up resistance in a parallel, you have to use this. Okay. So equal to 1 over R1 plus 1 over R2 plus 1 over R3 and reciprocate. Okay. But there is if only in parallel, if only have two two resistance, you can also use this. Okay. Okay, imagine this, sorry, R1, R2. Okay. So R total equal to 1 over R1 plus 1 over R2 and reciprocate. Okay, another, if only two resistance, you also can use this one. R1 multiply R2 divided by R1 plus R2. Actually, it's similar lah. But if you have R3, so no, you have to use this format. R3 equal to R1 plus R2 plus R3 reciprocate. Okay. Okay, let's see example. Right. So please remember this one. This I make star here. Okay, this is example of parallel circuit. So we have a voltage supply of 12, and then we have a resistance in parallel 6 and 3 ohm. Okay, so the question is find I here at outside branch and find the R inside the branch. Okay. Okay, so first step, as usual, we want to know total resistance. Okay, so calculate total resistance using this method. 6 multiplied by 3 divided by 6 plus 3, you can get 2 ohm. So at this parallel circuit, R at parallel similar is equal to 2 ohm. Resistance at parallel, total 2 ohm. And then step number 2, we calculate total current. Okay, so means 12 volt divided by 2 ohms, this one. Okay. So the current is 6 ampere. So where is the 6 ampere? 6 ampere here. Okay, so 6 ampere will flow here. Until before junction, it's still 6 ampere. But then the current will be split. Okay, will be split. So what is current here? So let's look what is the resistance here. Okay, so since we know we have only one parallel. Okay, we have only one parallel, and the voltage is similar because only one parallel here. So we can calculate I1 equal to V over R1. Okay, means 12 volts divided by 6. So here is 2 ampere. 2 ampere going to left. And then current at R2, V over R2 means 12 volts divided by 3 ohm. So we can get 4 ohm. So here to the right, 4 ampere. All right. So can you see, originally 6 ampere, and then depend on the resistance on the branch, current here will be 2 ampere, current go here will be 4 ampere, but total 4 plus 2 is 6 ampere. Right. Okay, there is, right. Let's do another, yes, similar exercise. Let's change value. Okay, this one I changed to 24 volt. Okay, this one I changed to 10 ohm. This one I changed to 5 ohm. Okay, and calculate each I. So remember, the step is to find R total first. Number 2, to get I. And number 3 is I1 and I2. Using this, this is 5. Okay. If you're done, you can write your answer in the chat box. Okey, ada yang dah berjaya jawab belum? Uh, Pan Kang Bao dah dapat Okey, ada rakan kita yang dah dapat. Tapi saya tunggu lagi seorang. At least supaya dah double check jawapan Fan ni. Okey, Haikal dah dapat, baru nak tulis. Boleh teruskan. Hampir sama. Okey, Fan pun dapat R equal to 3.33. Okey, jawapan seterusnya Kemal. Okey, Kemal dah bagi that betul Okey. 7.2 7.21. Alright, dua jawab saja. Okey, current 2.4 4.8. Okey, dua orang dah dapat jawapan sama. Saya assume betul tak? So R total is 3.33 ohm. I equal to 7.2 ampere. And then I1 is 2.4 ampere. And this is 4. Yeah. So ada yang tak dapat jawab tak? Okay, step dia sama macam yang ni similar step. So this is the answer for this one. Alright, so I believe all of you take note. Okay, until here ada question tak? Do you have any question? Tak dapat sama macam ni ke? Okay. Alright. So that is, if no question, so that is about a parallel circuit. Very straightforward Okay, we will move to next one, which is a combined circuit. Right. After this, we rest and then we do exercise again. Okay, we continue a little bit. Okay, a series parallel circuit has some component series and other in parallel. So basically, it is combination. Some of it is series, some of it is parallel. Okay, by the way, since this has a lamp, okay, basically what is resistance in Ohm's law circuit? So resistance actually is actually equipment, devices that only use resistance, such as lamp or anything is devices that has resistive element only. Okay. All right. How to explain this? Okay. Basically, combined circuit. It is you can draw like this, like simplify. So there is one resistance outside from the parallel. Okay. Something like this lah. This we can say as combined. Okay, which one is series? Series means the relation. This is R1, R2, R3. So combined circuit is combination of series and parallel. So which one is series? Series is the relation of this resistance and this resistance. Okay. This connection is series. Meanwhile, this parallel itself is parallel. Okay. You have to remember that. Okay. Another things for this example is actually a simplified. In case of okay, let's ignore about this first. Let's look into here. If in parallel there is this also can consider as combined circuit. So this inside a parallel has two resistance connected by series. So in this condition, normally we will we can simplify it. For example, R1, R2, and then we can combine it by sum up of this and represent one resistance. Okay, sorry dalam bahasa Melayu, kita boleh, jika keadaan ini, kita boleh ringkaskan dengan kita tambahkan jumlah dia, sumkan dia, jumlahkan dia lah. Dan kita akan dapat satu nilai yang akan represent resistance at this circuit. Okay, and then we can calculate as usual. This is another one example, and another example is like this. Okay. But in this example, we need to calculate different separately. All right, example number 1. So we have all is this resistance. We want to know total resistance. So inside this is parallel. So one of the branch has resistance connected by series. So what we can do now is we can sum up this first. Okay, 7 plus 5 equal to 12 volt. So we can say that after we simplify, it become 10 ohm. And then series 12 volt and 12 ohm. Sorry, 12 ohm. 12 ohms and 12 ohms. And then 4 ohms. Okay. This one can be simplified. You combine and you can represent one resistor. Okay. So based on this, then you can calculate total resistance is 20. 10 plus 4 plus this one. So this one is 12. 12 plus 12. So maybe what? Let's see, 12 multiplied 12 divided by 24. This is equal to 6 lah. Okay. So 6 plus 4 plus 10 equal to 20. Right. I think this is too simple. Let's look into this one. Okay. All right. In this circuit, we have a connection like this. Like this one. Okay. So we have supply of 12 volt. We have one resistance outside. R1 is 5 ohm. And then we have parallel resistance connected in parallel, which is R2 and R3. 2 ohm and 2 ohm. And then we also want to know what is the current each branch and what is the voltage at here. All right. So we want to know I1, I2, and most importantly, what is V1? What is voltage here? All right, this is now you have to understand all the previous knowledge, concept. Okay. Let's recap again about voltage. So voltage in series, voltage is different at each, right? Okay. So you have to sum up because it's in series. Because series, you need the voltage shared dikongsikan pada setiap resistor. Meanwhile, for parallel, if only one parallel branch like this, so we can assume it is the voltage is similar here and here also 24. Okay, so what happened in this question is this is actually the relationship between this parallel and this single is actually series. Okay, so you cannot use 12 volt. You cannot assume 12 volt is here. Okay, because this is combined circuit, even though this is parallel. So, but this parallel and this one connection is series. That's why here has V. We can say this has V1 Here is V2. Okay? The parallel has its own V. Okay, so that is quite tricky. You need to able to identify these things. All right. So number one, first step, what we have to do is, as usual, calculate R total. So here has, okay, R total. We try to solve R total here first. R, sorry. So we can say that R series plus R parallel. Okay, R series plus R parallel. Okay. Then we try to solve R parallel first. Okay. So 2 ohms multiply 2 ohms divided by 2 this one, and you can get this R parallel 1 ohm. And then combine resistance. Okay, so it means total here is 1 ohm at R parallel 1 ohm. So R series is 5. So we have 5 here, and we can get R total is 6 ohm. Okay, correct. And then as usual, second step, we need to find total current first. So I equal to V divided by total uh, resistance, 12 divided by 6, which is 2 ampere. Okay, so 2 ampere. Start from here, it will flow 2 ampere. Main. Okay, 2 ampere. So at this single resistance, it will receive 2 ampere until this point. Still 2 ampere. So basically we know this is a series. So we know this resistance will have 2 ampere. So we can calculate what is V here, right? So V here means, we can say this V1. V1 equal to 2 ampere multiply 5. This is 10 volts. So here already use 10 volts. So what voltage left? V2 means 12 minus 10. Okay, it means 2 volts. So here at this area is actually 2 volts. Okay, now you can understand. So when we already obtain these volts, then we can calculate current in each branch. So let's say, uh, what is I1, I2? So I1 means V over R2. So V is 2, R2 is 2, so 1 ampere. And another one, because similar ohm, so it is similar lah. 2 volt divided by 2 ohm equal to 1 ampere. So go one branch is 1 ampere, another branch is 1 ampere. So total is 2 ampere. So am I clear here? Okay, boleh. So again, 12 volts, we get total current. Current will flow until it reach 1 resistance, and then that resistor will receive 2 ampere. So we can calculate the voltage. And next, go to the next one. When we already identify voltage here, we will know what is voltage here, and then we can calculate as usual the current through each branch. Okay. I think that's one. We will look into this example later, again later after we take a break. But before that, how to use this power equation is simple. Given electrical supply is 120 volts and the allowable current is 5, calculate power. So power is very direct. You just need to multiply voltage and I current, so you can get 600 watt. Okay, take a rest first, 5 minutes. and we will continue with let's see previous exam question. So we will continue at 328. 328. Or I will try to find the question first. Okey, kalau kepada sesiapa yang dah ready, you boleh cuba jawab soalan ni mungkin 10 to 12 minutes 10 to 12 minutes. So please use this new value lah. I write the new value. So 5 ohm here, 6 ohm here, 3 ohm here, 10 ohm here, 10 ohm here, 5 and 10. You can screenshot this figure, and then you need to find total resistance, total current, find V1 and V2, V at parallel, V parallel 1, V parallel 2, and current at each branch, all branch current. Okay. Okay, sorry, internet problem. Terputus. Okay, again. Total resistance. Ada siapa yang dapat dah? Okay, ada jawapan satu. Fan Kang Bao. Okay, 23 23 ohm. Okay, itu correct lah Ada yang setuju? (23), okay, Haikal pun dapat 23. Nak double check tak? Okay, kita double check lah Alright, here is R1, 5, and then at the parallel we need to solve this. So we can use, because only two resistance, we can use this equation. So 27 divided by 9 equal to 3. So this one is 3, and then 4, and then here, okay, here what you have to do, okay, this is 10, 10, 5, right? You have to combine this first. So total here is, oh sorry,
18 doktor. 6 darab 3.
oh sorry. Okay, sorry 6 multiply 3 is, okay, thank you sebab kan saya pun tak buat lagi sebab ni baru punya soalan. Maksud saya new value. Okay, alright, thank you. 18 divided by 9 so 2 2 ohm here, and then here 15, total 15 so at parallel means 15 multiply 10 divided by 15 plus 10. Okay, this 150 divided by 25. So I believe this will be 7
6.
6 1, 2, 3, 4, 5, 6. Okay, 6 6 ohm. Okay, then we can sum up. 6 plus 5 plus 2 plus 10 plus 6. Apa? No, 23 23. Okay. So we get 23. Okay, that is how you calculate total resistance. And then total current. Total current is very straightforward. We have already total resistance. Then what is the total current? Can you calculate for me? Berapa nilai total current? Okay, Pak Fazrul Amin. Oh, total current Amirul 0.43 ampere. Okay, this is come from where? This is from 10 volts divided by 23. Okay, then let me calculate. Right. 10 divided by 23. 0.434. Okay, you can maintain here. 0.43 is okay. Okay, find V1 and V2. Okay, so what is V1? V1 0.86 0.86 volts. V2 view dengan fun dapat 2.58. Okay, let's double check. First thing first, we have to know this first. Okay, because we already have this one. Main I is 0.43. Okay, it means V at here. We can say at V R1. We add R1. 0.43 multiply sekejap. Okay, saya cuba buat ni. Alright, okay, we straightforward. We can calculate straightforward. Okay, V1 equal to resistance dia berapa tadi? 2 V1 V equal to IR So we already have 0.43 I and then R. R at parallel is 2. So we can get V1 0.86. Okay, correct. And then V2 similar IR. I is 0.43. Meanwhile R total resistance here is 6. So we can get yes 2.58 almost volts. So this is correct. And lastly, find I for each branches. Okay. Alright, so we already know this is 0.86. This is 2.58. So I equal to V over R. So I here is V over R. 0.86 divided by 3. So this one 0.86 divided by 6. Similarly here 2.58 divided by 10. Because this is 10 and then here is 2.58 2.58 divided by this total is 15. Okay, so you can solve by yourself. So that is how you try to solve this circuit. All right, thank you for your response, your cooperation, very nice one. So for all of other students, hopefully you can remember this concept. Very important. In combined circuit, you have to really understand when to use the concept of parallel and when to use the concept of series inside the combined circuit. Okay. All right. Is there any question? Actually, I have one more question. This one, but I think you can screenshot. Maybe we can discuss next week. You can screenshot this. Maybe I can screenshot this one. But for your additional exercise. This one and then okay, this question as normal normally calculate find total, find I total and then find I at A and B. A and B kan? Find I at A and B. Right, this you can use for your own. Okay, I paste at the group. Okay. So okay, next week 14 actually 14 evening I have panel okay, probably next week will be online based on recorded lecture. But just in case, how to do? Rabu petang next week saya ada jadi panel. So mungkin kita akan buat online recording lah. Self running So next week will be electrical distribution, but Hopefully, because chapter 5 will relate to your project, so I want you to, just in case, prepare, find find example. Okay? For group project, is each group need to find, so your task, find one example of electrical drawing for residential house. Kalau ada lah, or residential house or small building lah. Macam mana nak cari? Try to find online first. Okay, so each group find online. Electrical drawing, electrical distribution. Example. I have example, but I want you to try to find your own drawing to make sure it can guide you in a project. This one. Okay, something like this. So if you have what is electrical drawings look like? So it has plan, it has symbol, it has some information on the fuse, the distribution of the circuit. So before we going to detail later, but please, if you have time, please find some examples so you can look first what is the drawing should be like, look like. So you will do like this in your project. Okay, you will do like this. So in your project house, you have to identify where is the light point, where is the fan point, where is the exhaust fan point, where is the aircon point, and then you have to do this one, this distribution. Okay. All right. But please find okay. The thing is, please find example, and then the example that you bring, actually, you give me, I will share to all. I mean, each group please find one, and based on your submission, I will filter which one is good, and then this example we can use to improve our knowledge. So I have one, so if you can find another, we combine and we look if there is a variety. Jika ada perbezaan, mungkin yang saya punya tak cukup yang ini, you punya ada ni, kita combine, kita lihat. So in the same time, if saya juga akan share lah yang ini juga. Okay, saya akan share yang ini juga. Just in case you don't find any. Alright, I think that's all for now. Hopefully you get this knowledge and calculation very simple. And to be note that calculation question is quite favorite in exam, and hopefully you can do exercise, make sure you can score. Calculation is a must to score because we already know what is the final answer. You will know your question. You will know you have marks or not. Okay. All right. I think that's all for now. Thank you for joining this class. So let's meet again soon. Okay. I will inform later. Okay, thank you very much. Assalamualaikum and good days.
Terima kasih, Doktor.